Heap sort iteratively executes two steps. Make heap, which put the max element at index 0, and then swap first and last elements. As a result, the element 10 is sorted. We repeat the process on the orange collection. After the previous swap operation, the orange collection is not a heap anymore. Hence, we first make heap and then swap first and last elements. As a result, 9 is sorted. Repeat the two steps on the orange collection, make heap, and then swap first and last element. Let's watch now how heap sort sorts the rest of the elements by iteratively calling make heap and swap. I will go through the same example to see how make heap works step by step, and afterwards I will present an implementation of heap sort in C++. This is Khalid and welcome to heap sort algorithm in C++. We will start with the heap data structure since it's the core idea behind heap sort. A heap has the following property. Any parent node is larger than its left and right children. For example, 10 is larger than 8 and 9. 8 is larger than 6 and 7, and so on. The binary tree view we see on the screen is just a mental model we use when working with heaps. Let's see how we make heap from a random collection. Here is my random collection stored in a vector, for example. And then we build our mental model, the binary tree, to represent our collection. A useful property of the binary tree representation is the following. If the parent index is I, then the left child index is 2i plus 1 and the right child index is 2i plus 2. For example, the parent node 6, which has index of 1, has its left and right children at index 3 and 4 respectively. We will use this property when implementing the make heap algorithm in C++. But now let's go back to make heap step by step. Before starting, I will replace numbers in the tree with small circles just to make the comparison easier. When making the heap, we compare the parent with its children and swap parent with the maximum child if it's larger than the parent. So we start from the last parent, which has children, and exclude the leaves. In blue, we have the list of parents that we will iterate over. And we start from the last one in the parent list and go backwards one by one until we reach the root element. Compare parent and child. Child is smaller than parent, hence don't swap. Pick the previous parent. Compare parent and left and right children. Here, children are larger than the parent. Hence, swap parent with the larger child. Pick the previous parent, compare parent and children, and swap parent with the larger child. Pick the previous parent, compare parent and children, swap parent with the larger child. Here is the child also a parent, hence we need to keep swapping if needed. After processing the root element, the heap is made. And now we can go back to our number representation. Now let's go outside our mental model, the binary tree data structure, and go back to the real data structure, vector in our case, and we get the heap built in place. Now let's see one possible way to implement heap sort in C++. Here is the heap sort template function. It accepts two iterators, first and last, which represent the collection we want to sort. First, make heap by calling the function heapMake. We will see heapMake in a minute. And then, as we have seen in the introduction, we repeatedly swap the first and the last element using std_iter_swap. After swap, the heap property is broken. We restore the heap property using the sift_down function, which takes the subcollection and the element at 0 index to be sift down. Now let's see how we implement the heapMake and sift_down functions. HeapMake template function repeatedly calls sift_down on the parent nodes, starting from the last parent and going backwards to the root element at index 0. And finally, let's see how to implement the sift_down function. The sift_down function accepts a range, first and last iterators, as well as a node index that we want to sift down. Get the node to be sift down and store it in parent, and store the size of the subcollection. Then start the loop from the left child. And for further sift down operation, we pick the left child of the left child until we are out of bounds. Get left and right children. If the parent has a right child, get the max child and compare it with the parent. If max child is larger than parent, swap them. Then make parent refer to the swapped with child. Else, if the parent has only one child, then compare with that child and swap if needed. And then make the parent refer to the left child swapped with for potential further sift down operations. And with that, we have the whole implementation of heap sort algorithm. And finally, to test our heap sort, we can use the following code, which will execute the same steps we have seen in this video. IOTA will fill the vector from 1 to 10, stud_shuffle will shuffle the collection, and finally call our heap sort algorithm. Thanks for watching.